Hello, and welcome to the next video in our C programming course. Today we're going to look at a sorting algorithm known as selection sort. Before we get started into things, let's just briefly talk about the analysis of selection sort. So it's going to be a stable sort, which means that the data that we're going to sort is going to maintain its relative ordering of elements. So that means that if we have the same element, if we have the same number stored in two different spots, if we sort them, the twos aren't going to get, the twos are not going to get swapped back and forth with each other. What's going to happen is the relative order of our list is going to stay the same. It's also an in-place sort. What does that mean? It means that it doesn't require any extra memory. The memory that we start with is the memory that we're going to need for the sorting procedure, and it is going to be efficient when the number of elements to sort is small. One con to selection sort is that it does require many movements. We are going to have to shift everything up an index, and we are going to have to swap elements as we do that. And it is efficient for lists that are almost sorted. So why don't we take a second here to jump into some pseudocode and look at an example. Here we have an array, and I've taken the time to label our indices of the array as well. Let's step through this example and see exactly how we are going to sort this array using selection sort. So the main thing that we want to do is start with this element 45 and then compare this with 23, kind of like we did in bubble sort. And then what we're going to do is we're going to place each element 45, and then if 23 is greater than that, we're going to want to swap that 45 with 23, and then we're going to have 45, and now we're going to have the rest of our array. So every time you can think of it like we're going to be shifting the entire array, the entire sorted array. So we're going to start with our first element, and we're going to build a sublist. As we take that sublist, we're going to store each indice that's just adjacent by 1 in a temporary variable. So for example, if we start with 45, we're going to just assume that 45 is our sorted sublist. And then we're going to assign temp to 23. And the criteria that we want to check is the first element in our sublist greater than the adjacent element? So is 45 greater than 23? Well, it's actually not. So what we're going to do is we're going to swap 45 with 23, and we're going to get 23 as our sorted sublist, and then we're going to have 45, 32, 10, 30, 12, 66, 28. Now this is going to be our new sublist. We've now appended 45 to it. So now we're going to get 45 in our new sublist. So we repeat the process. So we're going to go temp, and we're going to store 32 into temp. And then we're going to check the criteria. Is 45 greater than 32? Well, 45 is greater than 32. Is 23, the next thing, because we have more than one element in our sublist, we're going to check is 23 less than 32? So what that means is we want to insert 32 in between 23 and 45. So 23 is not going to go anywhere. And then 32 is less than 45, so 32 is going to go in here. 45 gets left out here. 10, 30, 12, 66, 28. Okay, now our sorted list is going to append the 45, so we're going to have 23, 32, 45, 10, 30, 12, 66, 28. We're going to repeat the process, so we're going to go temp equals 10 now. And we're going to check, is 45 greater than 10? Yes, it is. Okay. Is 32 greater than 10? Yes, it is. Is 23 less than 10? Oh, made a mistake. Is 23 greater than 10? Well, yes, it is. So as we go through this procedure, we're going to constantly check and see if the element is greater than the adjacent element, and then if it's less than the adjacent element. Because if it's less than it, we want to insert it before that element. So we're trying to squeeze in the element between its range. So for example, 10 is going to be less than all three of these elements. So we want to push that to the front of the sublist. So we're going to get 10, 23, 32, 45, yeah, 10, 23, 32, 45, 30, 12, 66, 28. Okay, now we're going to append 45 to our sublist. So we're going to get that big sublist here. So 10, 23, 32, 45, 30, 12, 66, 28. Now we're going to check criteria. Temp equals 30. Is 45 greater than 30? Yep. Is 32 greater than 30? Nope, it's not. So we're going to squeeze 30 in between here. We're going to get 10, 23, 32. Oh, 30. Made a mistake right here. Yeah, no, 32 is greater than 30. Just stepping through things too fast. Let's go back up. So it is greater than that. How about 23? Is 23 greater than 30? No, it's not. So it's going to be squeezed in right here. So we get 30, 32, 45, 12, 66, 28. Okay. And then we're going to keep on repeating this process. We're going to push, we're going to put 45, we're going to append 45 to our sublist. So we're going to repeat this process over and over again until we finally get this ordered array of 10, 12, 23, 28, 30, 45, 66. Yeah, 10, 12, 23, 30, 32, 45, and 66. Yeah. So that's what our sorted list is going to be in the end. But if you can see the process of how we're going to be swapping these and pushing, we're going to take the adjacent element and we're going to try and squeeze it into the element that is greater than and the element that it is less than. So we're just constantly selecting it and putting it into the right position. Selecting it, putting it into the right position. Just like if you had a deck of cards and you're trying to fit the right ordering for, you know, some cards that you're holding in your hand. You can think of grabbing a card and then putting it into a list of cards where the adjacent list is where the adjacent card is either less than the current card, and then the adjacent card to the right is greater than the current card. All right, so let's look at some pseudocode for this. So we know that we're going to have a for loop. Our outer loop is going to go up to n-1 iterations because we always start with that first element. So we're going to have for in I equals 0 to I less than n-1. Oops, and we need to add our counter, I plus plus. And what we need to do is on the first pass around, we need to assign that minimum index to I, just like we did in our example. So now we basically have that first element, like in our example, that was 45. Now we need to loop through the remaining elements. So we're going to use another loop. So for int j, and j is going to be equal to I plus 1. That's going to give us the adjacent element starting out. And what are we going to go up to for this loop? Well, we're going to want to go up to the end of our list, right? So we have to go up to n. So, well, j is less than n, j plus plus. Now the criteria that we have to check in this inner loop is if aj is less than a min index. Close that off here. And if it is, what we want to do is we want to swap the indices. So min index equals j. Finally, once we get out of this loop, we still have to check a criteria to do, we have to swap. Remember how we were trying to insert elements, so we're going to swap the elements. So if I is not equal to the minimum index, min index, so if some sort of swapping occurred right here, then we need to move the elements. We use a temporary variable, temp equals AI, and AI equals a min index, and a min index equals temp. Okay, so at the end of this, we will have a sorted list, and this is exactly what we just did on paper, going through that array that we just saw. So if you want to stop the video here and take a second to try and code this up yourself, we've gone through all of the code. All I'm going to do now is just implement it in C. All right. Let's go ahead and make a new folder here for our algorithm. So new folder, we're going to call it selection sort. And let's close these from the last video. And we're going to add we'll add two files, selection.c and selection.h. Okay, let's go into selection.c. Let's add our typical libraries that we use, standard library.h and standard input and output.h. And make sure everything's working. Int main, return 0, save that. So I'm down in the terminal now. I'm going to cd into selection, and we got selection.c, selection.h, so G++. Let's compile selection.c dash output selection.c. Okay, selection.c. Okay, everything's compiling just fine. Now we need to actually write our program. So first, let's define an enumerated type for the size of our array. So we're going to say max, and we'll say we have 10 spaces. So we'll need an enumerated type to store the maximum size of our array, and then let's create some temporary variables here. So we're going to have our int temp. Okay, and we're going to need an array. So let's go ahead and add here, put a comma, and let's call our array A. We got to put in our size of the array, so we'll call it max. And let's go ahead and collect the elements from the user. So for int, let's first let's add an n for how big the user wants to make the array, the n elements that the user wants to add. So n, and first we'll ask them, so printf, how many elements would you like to add to the array? And we'll add a line break there. Oops, something in C++. And then we're going to do scanf. We're going to use a formatted string, so %d for integer format, and then pass in a reference to n, so we can save that size of the array. And then we're going to loop through and get each element that the user wants to enter. So for int I equals 0, I less than n, I plus plus, and please, printf, enter element %d and \n, and let's put in an I. So what this is going to print out is enter the element for each number that that's in the index. So we're going to scan f %d, and we're going to pass in a reference to our array. So what the user's going to be able to do is enter an element into each, enter a number to be stored in each element. Now we're going to actually implement selection sort here. So we saw this in the worked out piece of paper. It's going to be the same thing. So for int I equals 0, I less than, our outer loop is going to go from I to n minus 1, I plus plus. And then the first thing we need to do is assign the min index, and we need to add that up here. Got to have our min index. Okay, so for the first thing that we need to do is you need to assign the min index to I. And now we're going to loop over that subarray. So for int j equals I plus 1, we're going to start at that first adjacent element. And then we need to go to the end of the array, I less than n, j plus plus. And we're going to check the condition if the jth element is less than the index stored at the minimum index, or the element at the minimum index. All right, so if a j is less than a min index, we're going to swap min index and j. Okay, once we get out of this loop here, next we need to see if those indices were changed at all. So if I does not equal the min index, we're going to swap elements. Temp equals AI, and AI equals a min index. A min index equals temp. Alright, now the last thing we want to do is be able to print out, all of our elements. So in the last video, I kind of showed you guys how to make a function that prints out all elements, but we didn't make it into a function. So guess what? Today we're going to do it. So void display array, and we're going to take an input array, and all we're going to do is let's also get n, the size that we're going to be looping over an. So for int I equals 0, I less than n, we're going to loop over all of the elements and we're going to print them out. I plus plus print f. Need an integer formatting. We're going to use a little break like that, and we're going to pass in AI, and then we need a line break at the end. So why don't we print, and this is the implementation. I don't want to have my implementation up here, so I'm going to go ahead and Control X, and I'm going to put my implementation down here. I'm going to put my definition up here at the top. Okay. Now we can use this function in our example to print out our elements before. So we'll do display array an before we do this sorting with selection sort, and then we'll do display array after we do our sorting. Alright, let's go ahead and just make sure everything works here. So I'm down here in the terminal, and I'm going to compile this. So it looks like everything is pretty good. Now I'm going to run proc. So how many elements would you like to add to the array? Why don't we do 7, just like in our video. So element 0 is going to be 45. 1 is going to be 20. Oop. What do we got going on here? See, we did not pass in a reference, so that's going to actually break. We have to pass in a reference to the array. We can't just pass in the element. Is that the only place we're using scanf for that? Looks like that's it. Alright, so let's save that. Let's compile it, and let's run it again. So 7 elements. Element 0 is going to be 45. Element 1 is going to be 23. Then 32, 10, 30, 12, 66. Oops, segmentation fault. What the heck is going on here? Seemed to break right when we got to 66. I think we're just running out of memory for the array. Let's make this into 1,000. I don't care. All right. And let's compile this and run it. So 7 elements, 45, 23, 32, 10, 30, 12, 66. 66 is breaking this when we do that. What are we doing wrong here? Okay. Oh. Well, yeah, this is the problem here. It has nothing to do with this memory up here. This was fine at 10. Let's go ahead and save that. What's going on is we're saying how many elements do you want to insert in the array, and we're saying 7. Well, let's do some dumb counting here, Evan. 0, 1, 2, 3, 4, 5, 6, 7. That's 8 elements. What the heck? Okay, let's just run the program again. How many do you want to insert? 8. So it's going to be 45, 23, 32, 10, 30, 12, 66, 28. Oh my God. All right, yep, because we're starting at 0 and it's going till it's less than n, and that's not going to work for us because I is going to be 8 at that point, and 8 is not less than 8, so we need actually 9. Let's run it again. All right, so 9. So 0, 1, 2, 3, 4. Oh man, I put in all the wrong elements. 45, 23, 32, 10, 30, 12, 66, 28. I don't even know, I just 0, 0, 0. Okay, so we're getting a segmentation fault. Made a small typo right here. This should be a J. I must have said J and then typed an I. So we'll save that. And now I need to compile that. So G++ selection .c-o proc. And now we'll run it. Oops. .proc.exe, and we want to do we want to do 7 elements, so we're going to enter 45, 23, 32, 10, 30, 12, 66. And I should have put in an 8 because we're supposed to have 8 elements, but as you can see, this is basically what we got when we worked it out on a piece of paper. Alright, so -1 for typos, but I hope you enjoyed this video, and if you like this video, go ahead and like and subscribe my other ones. Have a great day.